Good morning, guys, ladies and gentlemen. My name is Peter, and I'm one of the technology solutions professional at Microsoft Hong Kong, focused on the Azure app development technologies. So in the next section, I will be introducing the Kubernetes technologies and the Azure Kubernetes service to you. So previously we had David Day talked about the containers, microservices, and what coming up next is a really hot topic. It's really talking about the container orchestration. It's all about Kubernetes, how to manage containers in a large environment. So this will be the agenda for for my section. So I'll be spending an hour of time talk about what is Kubernetes to you, explaining the core concepts, and another section we will talk about the Azure Kubernetes services, which is a managed Kubernetes cluster on Azure, and I will also tell you what is the value of it. And the third part, we will go into the details of Kubernetes. So this section, I really hope to give you an understanding on how Kubernetes works. All the basic concepts will be explained so that you guys can have some basic concepts before going to the hands-on section in the afternoon. So stay tuned and focus on the technologies here so that you can learn and so that you can get prepared to understand more what will coming next in the afternoon. So without further ado, let me just begin and talk about the container orchestration thing. So David Day mentioned a lot about containers. I definitely I am sure that you know what containers are, right? So you have Docker and then package all the stuff inside a container environment. Imagine if you have a large amount of containers that you want to deploy in a production environment. In a production environment, usually you're not talking about just one or two containers, right? You're talking about thousands, hundreds, or even millions of containers. In such a large environment, how you manage those containers is a very essential component or essential things that you need to think about. So maybe let's take a look. So this is, so we have two VMs here, right? So within each VM, basically we have, several containers can be deployed. And imagine you have more and more VMs, okay? More VMs, more containers. At one day, you may become like this. A lot of VMs with a lot of containers, like thousands of them. Imagine if you want to manage those containers just by command line one by one. This will be a nightmare to you because you need to do them one by one at a time. And actually you cannot troubleshoot very easily. You cannot identify what's the status of the containers, how the application is running, because you have no ways to control. Everything is just like a chaos. So that's why we have something called container orchestrations. So basically we have another component, okay, like a master, okay, like a leader to control the behavior of the containers in a centralized manner, okay. So we call it container orchestrator. So out there we have a lot of options, right? So we have different brands. This is the first one, DCOS. Another one is called the Docker Swarm, right? And the third one may be Kubernetes. Actually, these three they compete a lot in the past several years. But it turns out, who is the winner? Kubernetes. Kubernetes is the winner, definitely. And it already became the de facto standard and also the industry recommended approach to do on container orchestrations. Why? So I will show you later on what are the powers of Kubernetes. So what is Kubernetes? Kubernetes is basically an open source project, meaning that no one is really owned the product. It's really driven by the open source community. So you can find the code on GitHub. You can download it on Kubernetes website. And of course, different companies, including Microsoft, have different distributions. So different cloud vendors including Azure, including AWS, including Google. They have different kinds of, distribution and host different Kubernetes services. So what it really provides is an automated deployment. So automated scaling and also the ease of management for you to host your containerized application in a large scale. Okay, it's not just talking about 1 or 2 containers. It's talking about thousands of them or millions. Okay, so here are some fun facts about Kubernetes. So Kubernetes, this word sounds kind of complicated to be pronounced. Okay, this kind of mouthful. Actually, it's come from a Greek word. Okay, meaning a pilot, just like the master. Okay, controlling everything, just like a pilot controlling the ships. Telling which ship should go where. And why we call K8S is really just because there are 8 letters in between K and S, just for your information. So at Microsoft, what we are doing, actually we are providing the managed service on the Kubernetes service to you. We call AKS, Azure Kubernetes Services. So what AKS really provides is a bunch of built-in service that already available for you to consume immediately. Traditionally, if you want to deploy a Kubernetes cluster, you have to download the source code and then install each component one by one. API servers, the controllers, the schedulers, the kubelet, all of the things you have to install them one by one in the master nodes and also in the worker nodes. And after you install, you need to install a lot of plugins like network configuration, storage, a lot of things. So that really takes a lot of time. Imagine if you're a business, you are talking about we are talking about agility. So how you can leverage the cloud platform to help you to deploy things faster rather than spending weeks or even months to provision the cluster, just focus on the infra, not focus on your business logics. So AKS really helps you to deploy very quickly. What you need to do is go to the Azure portal, type a few lines of command. All the deployment will be automated, and you can get your cluster within a minute. And another benefits of using AKS is all the master nodes. So master nodes are the pilot orchestrating the containers. They are all managed by the Azure platform, meaning that you do not need to install security patches. You do not need to worry about the the patching, the backup, and the availability of the master nodes. And only the worker nodes will be charged. Worker node means the VMs that you used to deploy your containers. So you can have one worker node, or you can have hundreds of worker nodes. That's up to you. Okay. And for those worker nodes, securities will also be patched or in an automatic manner. And one of the things that really just need you to be aware of is whenever there's a security patch, you need to reboot the VM. That's how AKS works. But the security patch will be installed automatically. Another thing is available in Hong Kong, so that you can if you have data sovereignty requirements, or you just want to deploy your application within Hong Kong for whatever reasons, for compliance reasons, for availability reasons, just feel free to do so. So it's available in Hong Kong region. And actually there are a lot of features around Kubernetes. So most of them are available on AKS, including what? Including the container level and also node level auto scaling. So container level, auto scaling, they call somehow they call it horizontal pod auto scaler. Okay, so it is available on AKS, and then node level auto scaling, meaning VM, is also available. Again, security patch will be installed automatically. Another one is about the day 2 operations after you deploy. Imagine if you have a cluster that runs for like months, and then Kubernetes community decided to launch a new version of the Kubernetes. So if you using the traditional way, installing your cluster one by one, or in a manual approach. So upgrading a cluster is really error prone, because it really requires you to do a lot of command line operations to make sure you upgrade in the correct manner. But on AKS, what you need to do is just go to the Azure portal, just go to the command line interface, just type, AKS upgrade, and all the things will be, upgraded in an automatic manner without any downtime. So if you want to upgrade from 1.11 Kubernetes to 1.12 or even 13, so you can do that by command line. Integration with Azure AD, integration with Azure Monitor are all built in, so that you do not have to install any Prometheus monitoring solutions. You do not need to install authentication servers, because all the things are out of the box. And again, if you want to leverage open source technologies, so a lot of people are using Nginx for like reverse proxy, or like other service mesh technologies, other kind of stuffs. So feel free to deploy it on the AKS. It's all supported. I mean, it's all deployable. Okay, it's all deployable on the AKS. Network policy meaning is a feature. It's a new feature in Kubernetes, meaning that you can control how the containers communicate with each other. For example, if you want to limit container A and container B, the communication between them, you can do that by network policy, and it is supported by AKS. Port security policy, meaning that you can have this feature to control how a container can get privileged access or access to the host resource, like whether you allow a container to get root access, or allow the container to mark a drive, something like that. You can do that on AKS as well. So it's work like this. Okay, imagine you want to deploy AKS. Just go to the command line and type these few lines of command. AKS create. Okay, after like several minutes, install the command line, and then get the credentials, and then start using the kube control command, so that you can enjoy the benefits of the AKS. So you can start using it immediately. After you deploy, of course you need to manage, right? Manage all of things can also be deployed using the command line. Of course you can do that using other approach. For example, you can use the Kubernetes built-in UI to help you to do that. But another approach is you can use the kube control command, or use the Azure command line interface. So you can do upgrade just like this, just one command line, AKS upgrade, okay, from current version to maybe another new version, 1.8. And also scaling, okay, scaling the VM. So you can do that using a command line as well. You are not limited to use command line again. So you can use the Azure portal if you are more familiar with the graphical user interface, or you want to look at some graphics. Or you can use another approach, is use the ARM template if you guys are familiar with it. So how is the industry using AKS nowadays? Actually, AKS is relatively new, I would say, but actually it's already have almost 2 years of history. Okay, so during these 2 years, we see a great momentum within Microsoft. So exponential growth. Why? It's really because the Kubernetes technology is so hot, and all of the companies, all of the developers want to leverage such kind of technologies to manage a large amount of containers. That's why I see a lot of potential growth. Okay, so you can see a list, of customers here. Another thing that I would like to emphasize is Microsoft is really embracing the open source community in nowadays. I would say nowadays. Okay, maybe in previous year, like the 3 or 4 5 years ago, we are not like that, right? Everyone knows. But now, our CEO decided to change the whole culture, okay? And, we are not talking about, closed source. We are talking about open source. Everything we do with AKS, all the things are open source, so that you can find the AKS engine actually on GitHub. We call it AKS engine, okay? So you can, download it and then either install it on premises, on Azure, or on other places as well, okay? And another cool thing is we actually, recruited a very, distinguished engineer from Google, who is called Brandon Burns. So Brandon Burns, who is he? He is one of the founder of Kubernetes. So, and Previously, he worked at Google, but right now he joined Microsoft and then contribute to the AKS project. So he is the guy who leads the whole AKS and all the Kubernetes project at Microsoft. So because this guy is really somehow has a lot of influential power in the open source community. That's why Microsoft is also one of the largest company that contribute back to the open source again in nowadays. Okay, so another thing that I would like to mention is so we have a lot of features on Azure, right? Of course, you can leverage all of them, like Azure Monitor, the VS Code, the virtual network storage, container registry, all of them can be leveraged together with AKS. But of course, if you are already using another technologies, for example, if you're using Docker Hub or under other DevOps tools like Jenkins or Circle CI, that kind of stuff, feel free to do so. You're not limited to just use Azure technologies. On the top, actually, is third-party stuffs, and most of them are our partners. And including storage, the monitoring solutions. So pick whatever you want. So that's all about the AKS. Some of the basics. Of course, AKS is a very easy to use component because all the things can be automated. But after you deploy the AKS, what really important is how you operate, right? How you install your applications or how you give commands to the Kubernetes, right? So here I just assume that everyone is just new to Kubernetes first, because I know that not all of the people here may be familiar with Kubernetes. That's why I will start with the beginning to introduce you the basic concept of Kubernetes, so that you can understand more in the hands-on sections. So at first, I would just go through the standard architecture of Kubernetes. So this is not just limited, not really just talk about AKS. It's talk about all the normal Kubernetes cluster. Usually, a Kubernetes cluster has these kind of components. On the top, we have master node. Usually, we have at least one, but the recommended is 3 or 5, to have a high availability design. So in this master node, we have API servers. API server is really a key component of Kubernetes. All of the things, including external communication, like using the command line, or the internal component, like the kubelet, scheduler, controller, all of the things are communicated through the API server. etcd is the key value, distributed key value store for storing the Kubernetes state. Whenever you try to store some kind of stateful information or some kind of configuration files to Kubernetes, all of the things will be stored in etcd. And scheduler meaning is a component that will keep monitor whether a container should be deployed through the API server. And the container, the scheduler will work with the nodes, so that like a pilot, driving the containers where to go. So the scheduler will ask different nodes to schedule the containers. For example, if I have a new container, and then scheduler will say, hey, node 1, please install or run this container. Node 2, please run another container. So that's how this scheduler is being used. Controller is really used for monitoring the containers, the state. Whenever you have the scheduler deploy a container, so after you deploy a container, so Kubernetes will make sure the containers are in a healthy state. So who is in charge of this responsibility? The controllers. So at the bottom we have nodes. Nodes, actually we have 3 parts. The first part is called kubelet. Kubelet is think like a small program that interact with the API server and the master nodes, so that do regular health checks and report back all the status and the health condition back to the master nodes. Kube proxy is like a network component, so that it helps the containers, container to container communications to be established, and also help to expose the container pods to the outside environment. And the third one is called pod. So pod I will explain later on. So we can look at this diagram. Is usually we have containers, right? But in Kubernetes we seldom call it containers. We call it pod because pod is just a name for multiple containers. For each pod you can have multiple containers. But in usual case you will have just in a simple design, you will just have one container per pod. But of course, you can have multiple containers within a pod to have different designs. So whenever we try to say pod, remember it's talk about container. Okay. So pods actually will be scheduled in the worker nodes. So actually, usually we will not schedule the pod in master nodes because master is usually used for orchestration. So pod may be in node 1. Okay, pod A, B, C, okay, another node maybe have another pod, okay, but you can see that maybe somehow there are some pods duplicated, maybe in node A here, node 1 here, you have pod A, another node may have another pod A. Why? Because we have another concept called deployment, okay, well I will explain later on. When you interact with the Kubernetes, it's all about defining the desired state. What does it mean? After you deploy your Kubernetes cluster, if you want to configure your Kubernetes, what you usually do is to define something like this on the right hand side. It's a YAML file. The YAML file is a definition of your application. Okay, someone is calling it like an infrastructure of scope. Okay, and within this definition, you define how your application should be run, how the application should be exposed to the internet or to the network, and what drives should be mounted, what are the resources, and what are the limitations, what are the requirements. All of the things will be defined here. So remember one thing, this YAML file is very important, okay, because it really is the key thing that that requires you to interact with the Kubernetes. Whenever you try to interact or try to give commands to the Kubernetes, you define a YAML file. After you define a YAML file, you run this command, okay, kube control apply, and then -f, and then your YAML file. -f means file, okay. You pass in the file to the Kubernetes from the kube control command line, from your client PC or your Jenkins, DevOps machine to the master nodes via the API server. So that is very important because later on you will try this by yourself in the hands-on section. You will see a lot of times you need to write YAML files. Okay, let's go back to the topic of how to deploy containers, right? Again, pod is really about containers. So on the right-hand side is a YAML file. If you want to deploy a container, a Docker container, what you usually need is the Docker image name and the Docker, the path to the Docker registry, right? So as you can see on the line 9 here, you can give the name or the path to the registry in the YAML file, okay? And you can give it a name, like this one is called ratings web. And from line 10 and 11, you can tell Kubernetes what pods to be exposed, okay? Just like Docker images. So you define this using this format. But what is the power of Kubernetes? The power of Kubernetes is not just helping you deploy one pod. It's helping you to manage a lot of pods or containers. Deploying one pod doesn't help you to guarantee the desired state. What does that mean? It means whenever the pod or container fails, Kubernetes will not help you to do self-healing. What does self-healing mean? Self-healing means whenever there is a container that fails, Kubernetes will help you to redeploy the containers automatically in a defined in a defined manner. So in order to have this kind of self-healing capability, usually you need to create something called deployment. Okay, as you can see in the line 2, you define kind and then deployment. Okay, it's not kind pod. But here, the spec here is actually similar to pod. You define, what is the container image, what is the name, what are the pods. And then another thing, you need to define how many replicas of the container. In this example, we have 2 replicas, meaning that Kubernetes will help you deploy 2 containers in different worker nodes. This works like this. Okay. First, we have the YAML file. Okay. Through the command line interface, we pass it to the master node, right? Using the kube control apply command. After that, because we have 2 replicas, right? Imagine we have 2 nodes. Okay. This example is just 2 nodes. Of course, you can have larger amount of nodes, like 3 or 4, or even 10 or hundreds. But this example, we just have 2 VMs or 2 nodes, and 2 replicas will be deployed on each VM individually. Imagine, okay, what if the container fails for whatever reason? So the reason could be the code corrupted, the out of memory issues, or the network traffic has jammed a lot of things, and then the pod cannot be connected. What Kubernetes will do is actually they will have the controller, right? Previously in the architecture we have the controller. The controller will keep will keep asking the kubelet, hey, is this container alive? Is this container alive? Is this container dead or not? Whenever the kubelet said, oh, this container is dead, then Kubernetes will send another command to another node or another, or the same VM, okay, to redeploy the thing. Okay? It could be on the same node as long as that node doesn't fail, okay, or another node, okay? Doesn't matter, because as long as Kubernetes can guarantee there are 2 replicas, it is fine. Another scenario is what if the VM, okay, the node completely fails, okay, goes offline. Again, Kubernetes will try to do self-healing. This time, the kubelet doesn't really send a message back to the master node, but the master node itself will automatically know, oh, there are no signals from this worker node, then it will redeploy, consider it as a failure, and then we deploy the container to another VM, like this. All of the things here are done automatically. Why? Because you define the YAML file. You are telling Kubernetes that for this application, we must guarantee there are 2 replicas, no matter what. So Kubernetes will help you to do the job. So then it's one of the most powerful features of Kubernetes, and that's why it really have a large amount of noise, and also get a lot of community support when Kubernetes launched back in several years ago. And the Docker Swarm and also other container orchestration technologies, just like a following Kubernetes approach and do similar things. Okay, that's how you deploy containers using pod and also deployment. After you deploy the containers, usually you want to expose or get a public IP to access the containers, right? In the previous diagram, I'm sure you remember there are several lines that talk about the container pod, right? So in here, we can see how the container networking works. Actually, Kubernetes has itself a software-defined network inside. So all the pods or the containers within the Kubernetes cluster will be able to communicate directly, using the internal software-defined network IP address. So this IP address is not really the IP address that you get from the Azure, virtual network. It's different because it's an overlay network. Okay, it's a software-defined network. Okay, but within the Kubernetes itself, you can use this IP address to communicate between containers between the containers and containers. One of the things that you need to remember is pod are ephemeral. Ephemeral means it is not static like VM. It will come and go at any time. Just like the previous example, it will be dead at some point, and then being recovered at some other point. But when it recovers, the IP address and also the storage will be completely gone, will be completely different. That's why you cannot really rely on the pod IP address to do any applications dependency mapping. Just like this one. Imagine I have 4 ports with different IP address, okay, inside the Kubernetes software-defined network. When a client could be another pod within the same Kubernetes cluster, or some other PC or users tries to interact with this pod directly using the IP address. What if the container or the pod fails? So it will go away, right? But when the Kubernetes starts to recover by using the self-healing approach, it will generate another pod, but with different IP address. So the problem is, so the client cannot connect anymore because the IP address is different. That's why we need something called service in Kubernetes. Service is a Kubernetes resource, just like the YAML file that we have seen. So you can define kind : service to specify a reliable IP address. Just as it works like a virtual load balancer. In front of the pods, you can define a service, and the service you can ask to load balance the traffic to different pods. But this time, the IP address is reliable, meaning that it is static, so that the client or other pod can rely on that. So, like this. So I have a service definition, and then I specify the kind of service, and then the type I specify as cluster IP. Okay. For the type, actually, we can have cluster IP or load balancer. So I will explain the difference later on. And then you define, different parameters. So what are the pods, and what is the protocol, and selectors. So selectors on line 8 and 9 are very important. So selector means, so let's go back to here. So different pods usually have different labels embedded. So this label embedded by you, so defined by you. For example, I have a pod, 4 pods here. I can give them labels like rating webs. So how do the service know which pods should be connected to? It's all by labels. So that's why your definition in the service needs to have the selector, okay? App rating webs like this. Like this one. So this is deployment, right? So at the beginning, I need to define a label, okay? App ratings web. So this label must be the same as the service label so that they can be connected. Otherwise, they will not connect like this, okay? So there are 2 types of services in Kubernetes. I mean there are like quite many types of services in Kubernetes, but the most important 2 are the cluster IP and also the load balancer. Okay, so cluster IP means it will give you an internal IP within the Kubernetes software-defined network, so that you can use this reliable IP address to communicate between the containers. But there's one limitation: is you cannot use this IP to outside of the Kubernetes, meaning that you cannot use this IP address in an Azure virtual network and call it on premises, call it in other places. This will just work within the Kubernetes. Another example is like this. Okay, I have a deployment. Okay, I deploy 2 containers or pods, and then I have another YAML file service definition, and then I have another created a virtual IP. Other pods can use this virtual IP to communicate with the pods in a reliable manner. Another thing is load balancer. Load balancer is really having an approach for you to deploy an Azure load balancer on the cloud, so that it helps you to expose your service or pods to the outside world, okay, to Azure virtual network, to on-premises, or to other environment, or even to the internet. Example, deployment. I deploy 2 containers, another YAML file I deploy, but this time I have a public IP address, and then it will also automatically create an Azure external load balancer. And this external load balancer will automatically be configured to connect to different pods. So how you do that is using the service definition. What you really need to do is just to define the YAML file and then push it to the Kubernetes master. Another topic is about scaling. As I previously mentioned, there are 2 kinds of levels when talking about scaling. The first one is about the pod scaling or container level scaling. To scale an application or a deployment is very easy. imagine we have a YAML file again. Previously, we have 2 replicas. If you want to set it like 6 replicas, what you need to do is to change the YAML file and then run the apply command again. Deploy the things, okay? And then the Kubernetes will help you to deploy more containers in different nodes automatically. Another thing is VM level. VM level, you do that by using the Azure command line, the Azure AKS scale command. After you run this, so for example, I set the node count to 4, then I will create 2 more nodes. Another cool thing that Azure provides is something called virtual node, or something called a serverless pool with the Azure container instance. So what is the use case for this? Imagine you have a scenario. For example, your application is used to purchase singing contest tickets, right? Usually in Hong Kong, buying singing contest ticket is very difficult. You will, everyone just go to the website, and then all the tickets will be sold out immediately, right? At that time, usually the website will experience a great traffic, right? If you're talking about auto scaling, that traffic will just happen in like minutes. Within that minute, if your VMs, if your cluster start to scale when the ticket purchase period starts, eventually the VM will not get ready by the end of the people get sold out. I mean the tickets sold out, because scaling a VM, provisioning a VM requires like minutes of time. Okay, how to enjoy the serverless pool so that whenever you have a peak traffic or burst traffic, that you can grab resource immediately. Actually, you can use the virtual node with the Azure container instance. So it works like this. Of course, you need to run some command line to enable it. After you enable that, imagine we have a large amount of VMs available. It's in a hot state, meaning that all the things are already provisioned or configured on Azure. Okay, but it's not yet tied with your AKS cluster yet. And whenever you have some kind of traffic and you configure, of course you configure the auto scaling using the command. Whenever you have a lot of traffic coming in, with the ACI plus the virtual node, the AKS will ask, oh, we don't have enough virtual machines here, but now we have the virtual node here. How about we leverage the serverless pool so that we can get the resource immediately rather than having minutes of time waiting for my VM to spin up. So you can deploy like thousands of containers in the container instance pool. So this pool is shared by different it's a multi-tenant service. It's shared by different customers. But as long as you need it, you can use it. As long as you don't need it, you can just move it away. So all the things are ready. So you don't need to wait for the VM to provision and wait for minutes to get started. About rolling updates, another great feature that Kubernetes provides is the beauty of having you to run command lines of code to roll application updates. Previously, when you want to roll updates, you have deploy a new thing. Deploy a new deployment. And then whenever you want to try to roll back, you need to do a lot of configuration, a lot of things, right? But here, what you need to do is just run a simple line of command, just kube control, rolling update, and you specify the new container image with a new tag. So what it does is, again, you run this. Of course, you can use a YAML file or use a command line, and then it will start to deploy your new application one by one. Okay, how it works is like, of course, you can configure. Okay, but the normal approach is, imagine you have like 5 replicas of your containers. So what it really trying to do is it will terminate the containers one by one. So imagine you have 5 replicas and all of them are in version 1, and you are going to try to deploy version 2. So the Kubernetes will terminate one pod at a time and then deploy another new pod version 2. Once it's ready, and then move on to another new pod, another old pod, delete another old version 1 pod, and then deploy another new version 2, one by one. So it will not just go and terminate all the version 1 and then deploy version 2. You can configure that, okay? And of course you can configure some kind of delays in between. Okay, for example, if you want to delay like 5 minutes or 1 hour before another replicas get destroyed and redeployed, you can configure that as well. Another thing you can do is to use Kubernetes to do blue-green deployment. Imagine we have a again version 1 application. Then I give a label there, like label A. Okay, so this kind of pods we have a label. Remember the service types with the label, right? So I can configure that service, okay, please connect to label A pods, right? So what you can do is to create a new deployment, of course, using another YAML file to deploy a version 2 application. Okay, like this, but with different label, with label B. So the service right now doesn't point to the new version. After you do some kind of checking using the command line to make sure the new version really works, then you can configure the service, okay, change the label from A to B, and then the service will now point to the new pods, the new version. So another feature of this, imagine if you want to roll back for whatever reason. For example, the version 2 doesn't work or somehow it generates a lot of error. If you want to do a rollback, it's very easy. Just change the label from B back to A, and then it will just become like this. Okay. Okay, the last thing is about storage. Again, in Kubernetes, I mean not just Kubernetes, it's about containers, right? Containers are ephemeral. Again, meaning that you cannot really rely on the storage unless you are doing caching or somehow you do not care about the persistence of your data. But if you care about the persistence of your data, then you probably don't want to store your data inside a container, because once the container is done or terminated for whatever reason, either it fails or finishes the executions, it will completely gone and start a new one. So people usually do is to rely on the external volume, mount a drive or use the Azure blob storage or other things, or NFS storage, something like that. In Kubernetes, they have a lot of options. Of course, these are just some of the examples. So the first one is something called empty dir. Empty dir means is again it's just this, as the name suggests, is empty directory. But this empty directory is really saving the things inside a container. Okay, usually you use empty dir just for cache or non-persistent data purpose. So you can use that as with a RAM or in a hard drive. But the important thing is usually people use is the persistent volume. On Azure, you can use AKS together with the Azure disk, so that you can mount Azure managed disk back to your containers, so that you can store your persistent data inside this, and then use a mount drive approach to mount back to the containers. So they call it persistent volume. The approach is usually like this. Usually we have an Azure admin that has the capability or has the permission to create the Azure disk on the Azure portal. And he or she will go to the Azure portal or Azure command to create a disk first with a name, right? And then they will pass the name to the developer. So the developer will go to the YAML file and then specify the ID of the disk, so that the AKS itself will help to mount the drive, help to mount the Azure disk to his or her pod, like this. So this is approach. Okay, create the Azure disk using this command, and then the second approach is to get the ID and then paste it to the pod or deployment definition. So I hope this doesn't get you overwhelmed, because I think there are a lot of maybe new concepts to you if you're not familiar with Kubernetes. So no worries, later on we will have hands-on labs so that you can have a hands-on experience for you to try. But just remember all the concepts here, because later on you will be using that in the later stage. So that's all about my part. So congratulations. So I hope you get some kind of understanding. And maybe you guys thinking that, oh, I have to, finish all the things about Kubernetes, I've mastered all the things. But actually that is not the case, because Kubernetes is such a huge topic. If you go to, go to an online bookstore and then buy a book, find a Kubernetes book, you will find, hundreds of pages, like 600, 700 of pages explaining all the details of Kubernetes. So what I just skimmed are just, like several pages. Of course, these are really interesting topic and also hot topic. Everything is evolving and change very fast. But personally, I think is another industry trend that is coming or already here. So get yourself prepared, and I hope you enjoy learning this kind of technology. So this really summarizes what we have discussed. So I hope you can learn something from my section. So thank you very much for listening and attending my section. So you can download my deck here in case you have some kind of questions or somehow you want to look back into the deck for reference purpose. You can download it. Yeah, that's all for my session. Thank you.